Okay.
So yeah, so Andrea, please, if you don't mind to present. Sorry, Marco, if you don't mind to present Andrea.
Okay, sure. Okay, so let me. Okay, I can introduce Andrea. Andrea is a chief editor at Nature Physics. He joined Nature Physics in 2014, and he had previously worked for Nature Communication and Nature Materials. So he graduated from University College London, where he completed his PhD in statistical physics. Then he did a postdoc at the École Normale Supérieure de Lyon in France, and then he worked as a postdoctoral researcher at Uppsala University in Sweden. That's actually when I met Andrea. So actually, Andrea, I see you have Uppsala behind you.
Marco, you know what this is? Sorry, guys. You remember this?
No,
È del treno. L'ho preso dal treno. Yeah, sorry.
Okay.
Don't do what I did, girls and boys.
So,
it's illegal.
Okay, so so Andrea, you were born in Italy.
Born in Bologna, Italy, but Genovese by, shall we say, extraction. But I spent most of my life actually here in Britain. My life was a continuous migration north until I came back south from Sweden.
Okay, yeah. So, but you see what he has behind what he just showed you is, so you can blame it on his Italian part. And anyhow, then after that, so in Sweden he was investigating the dynamics of low-dimensional magnetic systems, and so now okay, Andrea is working as chief editor at Nature Physics, and he's based in London. Okay, so let's probably it's much more interesting to hear from him rather than from me. And again, Andrea, thank you for giving this talk, and we look forward to hearing something about nature journal.
So thank you, Marco. So firstly, it's really a pleasure to see Marco. I have not actually seen him for some time now, and I'm sorry, I should have logged on a bit earlier, but it's early in the morning for me, and I was getting ready for school and stuff like that. Yeah, I just like to also thank David for inviting me to speak to you guys in Singapore. And I just want to mention, yeah, I met Marco when he was a PhD student. It was clear he was very good back then. And so, it's a very pleasure for me to see him still doing research now. One of the things I get to do as a chief editor of a physics journal is I get to see people's careers develop over time, because I work with researchers over many years. And it's kind of interesting. I kind of have a feeling about, oh, this PhD students, like, they're doing really cool work. I like the way they conduct themselves. And then 5 years later, they're an assistant professor somewhere. It's always very gratifying. Anyway, I'm going to give, if I can change slide. Yes, I can. I think it's fair to say that the first thing people think of when it comes to a journal, possibly the journal that I work for, like Nature, is it's a black box, in the sense that no one, you know that there is an input, that something happens, and then there is an output in the, so the input is your submitted papers, the output is the published papers. Nobody really understands if there is any rationale or logic to what goes on inside this black box. What I hope to do today is kind of give you a bit of an idea of what goes on in this black box, and hopefully convince you that there is a degree of logic to how we operate. Just start with some background. There is actually a long and distinguished history of publishing. It goes back, depends whether you look back at the British academic system or at the French academic system, but essentially in the mid 17th century, sort of papers started being published as a way of kind of keeping notes of what was being discussed in the academic societies of the time. So the Royal Society in London, or the Académie Scientifique in Paris. I actually, probably it's not called that, but anyway. And then over time, sort of more outlets came out. And Nature, we like to say we're old, but actually we're not the oldest. The Nature is now 150. I think we're turning 152 this year. But we're younger than the New England Journal of Medicine, than the Lancet. Science was launched after us. and so on and so forth. And I think the key thing which distinguishes Nature is that we have a twofold mission, which is actually was articulated in our first ever issue, which is we want to place before the general public the result of scientific discovery and help scientists learn about advances in all branches of natural knowledge. So on the one hand, we want to help scientists talk to each other, which arguably is now much easier because of the internet, et cetera, et cetera. But secondly, and this is still very relevant, we want the public to appreciate these great works of science in the same way that the public might appreciate a great car if they buy a car magazine, or great architecture if they buy an architecture magazine. So it's actually about raising the profile of science with the public. So, you know, the magazine Nature, quote unquote, we publish the most important results. Of course, there's a huge degree of subjectivity to what that means, but in principle, what we aim for is results whose meaning and significance should be appreciated by specialists and non-specialists alike. My example is always kind of a silly one, but if someone discovers a giant dinosaur outside my back garden, and it's like a whole new species of dinosaur, and it gets published in Nature, that's kind of something that you can imagine explaining to your grandparents, or like, you know, or to, you know, scientists that are not just, you know, interested in digging up dinosaurs. However, in the early 2000s, we realized that there was actually a tremendous volume of very good papers Nature was rejecting that were quite simply exceptional physics, for example, that, okay, clearly was very technical, didn't necessarily interest other life scientists, but, you know, physics is a huge field. So something carried out in superconductivity might still be very remarkable and relevant to other physicists. And so this notion of like a community-specific journal, in this case, Nature Physics, was kind of thought up and launched in 2005. And Nature Physics was actually, it was so the first one was Nature Materials, for kind of materials cuts through many, many disciplines in a way which is strategically more helpful than physics. Physics covers orders and orders of magnitude, but materials cuts through sort of, you know, life sciences, the physical sciences. So that's why we launched Nature Materials first. But the idea is to have a community journal. And of course, you can replicate this for various communities, and we've done this over the years. People often complain, I think understandably so, as to why there are so many journals. And I think that the answer to this question is kind of, well, you should see how many, you know, just the literature, you know, the growth of journals is a result of the growth of the literature. And there is this paper, which I would really recommend, published by a researcher, well, Santo Fortunato and some other network scientists. It's called The Science of Science, and it's published in Science magazine. And they basically take a sort of empirical analysis of the academic literature, and they essentially demonstrate that really it's actually just been growth ever since it was started in the 1600s. But particularly over the course of the 19th century, you know, you can imagine, sorry, of the 20th century, you can imagine all the literature being carried out in, you know, in German, in Europe. Then the war happened, everything moved to the States. Then there was the Cold War, and there was like huge literature in the US and the West and in the Soviet Union. Then China came online, and then it, you know, so there's always a region of the world where some sort of massive scientific activity has resulted in a massive growth of publication volume and a concomitant growth of journals. So, you know, this is something which we just have to live with. You know, it's really true. It's an exponential growth. And I think that from a physics, if you're just a physicist, and I should update this slide because it's slightly old now, these numbers will have only got bigger. You know, I'm not sure what the composition of the audience is here, but I imagine, you know, you are all researchers who will in the morning wake up and have some interests in physics. Now, you can't read thousands of papers at the same time. You can't absorb it all. So you have to choose. You have to kind of prioritize. And in some sense, journals are kind of attempts to bundle research according to interest, and according to, I suppose, standards, you know, according to field. And the only thing I really want to convey here is the sense of scale. So Nature Physics in 2016 published something like 150 papers. PRL, which is a fantastic journal. I mean, I know we're often viewed as being in competition. I think we're actually very complementary. PRL published on the order of 2,000 papers. So there's a real difference in scale here. And I think this also speaks to, yes, it is quite competitive to get a paper published in Nature Physics. That is kind of by design, because we really are very selective. And I think at this point, you know, a natural question arises. I ask this myself all the time, because I'm, you know, my job is to run this journal. I want to make sure that my job is actually useful, is actually a job that people kind of agree is worth doing. You know, there's the internet, like people follow the references, you know, there's archive, and, you know, now biologists have discovered preprint servers like 25 years after physicists, and you kind of go, well, what's the point of journals if information is free and is so cheap to access? And that's a very good question. And I think that there are a number of answers I can give to why it's still important to have journals. I think it's, firstly, as an author, it's important to reach the right audience. You can post your blog, that's lovely, but if no one reads it, or if no one knows it's there, that's a problem. A journal can help to, quote unquote, separate the signal from the noise. So, you know, there are lots of papers published in graphene. Which ones should be the ones where you direct your attention to? Journals help curate the literature. This is often very underappreciated, I feel. And I think the best way to understand it is as follows. You may remember a blog that you read in 2011 that you really liked on the LiveJournal platform. Well, good luck finding that again. It will have, you know, the platform will shut down. It's like, you know, the phenomenon of link rot. Even newspapers actually have problem keeping like their archive fully sort of accessible to the public in a perpetual way. Journals offer a kind of, here's a volume, here's a page number, here's a year, here's a DOI, it's there forever. And, you know, if the internet collapses, it will be in a library, you know, in print version forever. And this curation serves as a long-term kind of storage of information, which I think is, you know, that's actually the bedrock of the scientific literature. And finally, and I don't want to overemphasize this because it's good and bad, but journals help create a narrative for a field. I remember when I was in Uppsala, actually, you know, like if Marco, hopefully you don't mind me mentioning this, but Marco was working on a, you know, on a problem of ultra-fast demagnetization, you know, and there were paper, you know, I can't remember, there were some Dutch guys that published a paper. And then that inspired some work that Marco's group did, and they published a paper. And that inspired, you know, and these papers were published in the same journal in PRL. And then that inspired some other, you know, there was a little bit of a kind of a scientific debate about this. And, you know, these researchers were basically inspiring each other and sometimes possibly annoying each other. But there was a conversation, a debate that the journal was helping to sort of shape. And I think that over years, this actually has an influence. Okay, so what the nature journals do, I liken it a little bit to the organic process of making wine, but of course you can replace this with any other you know, process of filtration. But essentially we receive a lot of submissions. We will read them, and we will then find, you know, the ones that we think have the most potential and send them out for peer review. And then those that make it through this technical assessment, the peer reviewers are the people whom we ask for technical advice. You know, we accept sort of a proportion of those. And yes, you know, these numbers are roughly commensurate with reality. You know, we have an acceptance rate of between 5 and 7%, I would say, when it's all said and done. Of course, this depends a little bit on the subfield. This depends a little bit, you know, some authors are extremely self-selective and only submit one paper every 3 years, and they have quite a high chance of getting published. Other authors use a kind of combinatorial stochastic approach and send us everything that they do, and they have a, you know, a much lower rate. So, you know, this is just an aggregate summary. I think what really matters is actually the quality of what you do, and I'll describe that a little bit. One other thing I should mention is about nature journals, which is different from other journals, is we hire a full-time team of editors. So, you know, Nature Physics is, there's me, and there's 7 other members of my team, and we work full-time for Nature Physics. And we have no, you know, I don't I'm not affiliated to any other society, to any university. My incentives are entirely aligned with publishing what I think is the best physics. And you may disagree, but if I do a terrible job over time, the reputation of Nature Physics would be affected badly. And I think that the other issue I want to just remind you of, again, we only publish now it's something like 200 papers this year that we're supposed to publish. That's 8 editors publishing 200 papers. It really is very labor intensive. It's not a terribly efficient system from a point of view of the volume. And I think this is something which, again, I kind of feel is important to remind people of. The editors are basically, it's a bit like a football team, if you will. So we have positions that we identify in terms of, okay, we need a condensed matter specialist, we need a plasma physics specialist, we need a biophysics specialist. So every editor has their own kind of beats. Of course, it's a broad beat. I mean, I joined, my background was magnetism, statistical physics. I then had to deal with superconductivity when I was handling papers. So it's reasonably broad, but at the same time, it is defined. We keep up to date with what's going on in the community. When it's possible to travel, we travel. Otherwise, we do these Zoom events. We do a lot of writing, editing, and email correspondence. And what we really aim for in the journal is kind of a collegiate. It's a bit like a mini physics department. We kind of try to get along. We're interested in the scientific questions. We keep each other updated. We have regular meetings among ourselves. It's not each editor just does their thing and is isolated. We're really working as a cohesive unit. And I think that the makeup of Nature Physics reflects, sorry, I've got the thing in the way here. I'm just going to move in out of the way. It reflects Nature really is Nature Physics is a mini Nature. So we have this front half, which is the more editorial, commentary, books and arts, the kind of the magazine section, and the back half, which is the business end. It's like where the research is published, the articles and the letters and so on and so forth. I can give you just quickly some examples. Last year, we published this paper by the Andrea Cavalleri's group. It was like a light-induced anomalous Hall effect in graphene. I won't describe the details. All I want to describe is sort of the package that we put together around this. So, this got the cover. Then we wrote an editorial to explain the wider sort of trend in the field of manipulating quantum matter out of equilibrium and kind of looking for Fourier physics. There was a news and views written, I think this might be one of your colleagues, I don't know. I think he was in Singapore when he wrote this. But so we really try to give a perspective, which is not just that of the authors, of what this research means. So that's something that we do on a regular basis. Just to convince you that we don't just publish condensed matter physics, we also published, this is a paper I've always quite liked. All they did is they made antimatter and they made it sit there for 15 minutes. But, antimatter is not something that I necessarily thought was so easy to stabilize, to fabricate. And so, what we consider as an arresting result really depends on the field. If someone had told me, hey, I made a magnet for 15 minutes, I'd tell them, well, that's nice. Why are you telling me? But antimatter was a bit different. And so, this is a little bit the kind of stuff we look to publish. We're also very keen on publishing large scale projects that cover entire fields that are maybe underrepresented or maybe we feel deserve more attention. So some years ago, we did this thing on nuclear fusion. On the right-hand side, you can see the project on crystallography. We did an insight on dark matter. We've done one on quantum materials, actually with sponsorship from some research institutes, the Simons Foundation and the Gordon and Betty Moore Foundation, who at the time were very keen in kind of developing this field. So, what I'm trying to convey here is there is often this sense that, us and them, there's you, the scientists who are trying to work hard, a fence, and mean editors who just want to reject you and make your life hell. But actually, we're trying to and partly that's kind of true. And I'll describe a bit how it works in a minute. But it's also about celebrating the physics, the discipline. We are kind of your allies, and we want to make physics be on the agenda of policymakers, be on the agenda of other scientists, and generally kind of help shape its direction. Or we also published cartoons. So when we were 10 years old, the guy of PhD Comics did this for us. And he did this, which we were not allowed to publish for copyright reasons, which is, anyway, that's just for fun. So how am I doing for time? Okay, good. I'm about halfway through. That's excellent. I'll quickly describe the editorial process, which I think is really how this black box works. So, we receive a bunch of something like, on average, I think it's 60 papers a week across the journal. So each editor, is, if it comes into whatever plasma physics, it's assigned to this editor called Stephanie. She will read the paper. She will kind of take notes. She might share her notes with me. Or we have a system for like discussing these things, and we try to send the first decision within a week or two. And what we look for is some kind of fundamental advance in understanding with respect to the existing literature. So to make an example, you have like, the theory of everything, and so you want us to sort of consider it. And what we will basically look for is there an original new, is this an original new direction of research? Is there some sort of aha moment, some arresting advance? Is it conceptually novel? Does it have broad interest? Or maybe it's actually just a practical advance. You've made something which, a quantum computer that you can send email with. Well, that's kind of cool. So there's a kind of, like, we consider the merits of the papers based on what that field is sort of, where it is at that moment in time. And we're looking for kind of a change of direction, I suppose. Actually, I should here quickly let you know that The Theory of Everything was published in PNAS in the year 2000 by Bob Laughlin and David Pines. So in case you were wondering, it's all been done. I think this title is rather arrogant, but I think they were kind of joking. I think that, well, they were basically implying in this article that The Theory of Everything is kind of, even if you did find it, it's not really The Theory of Everything. It's actually quite a good paper. So once we send a paper out for review, and this is probably the most important influence that an editor has, is the choice of the reviewers. So it's really important that we find the right technical experts. And I always use the same example, which is someone submits to me a paper, a neutron scattering study of a quantum magnet that behaves like, that's fractionalizing in a way that is kind of cool. Well, you can be sure I will contact a neutron scattering expert. I will contact maybe, an expert in quantum magnetism and maybe a numerical physicist to understand, the fractionalization phenomena in these systems. It's helpful that these reviewers, we check for conflict of interest, so we won't contact your former PhD supervisor or a collaborator. We try to really look for people, if a paper comes from Germany, then likely our reviewers will be based in North America, in China, in really quite, we have a broad geographical sort of diversity. And what we really want is people to be fair. We don't like it when reviewers say things like, this is terrible, these guys should take up another science because they don't know what they're doing. Like, we want it to be a constructive thing. Often a paper is the result of months, if not years of work of young PhD students who have given it their all. The least you can do is give them some constructive criticism rather than make them feel terrible. So we try to encourage things to be civil. And actually, I think I have some data to convince you that we do have a broad pool. It's not just a club that we contact the same people. So this is from a few years ago, but all this plot tells you is on the y-axis is how many, so the number of reviewers, and on the x-axis is the number of manuscripts they have reviewed. So you can see the vast majority of reviewers have only reviewed one paper, something like 5,000. And there's two reviewers who reviewed over the course of 10 years of Nature Physics, 12 papers. So, or 13 papers, sorry. So what I'm trying to say here is we have a kind of a rule of thumb as we try to not contact the same person more than twice a year to review for us. And I think that we, broadly speaking, are able to stick to this. And so, this means that we always have to find new people. We're looking for young guys as well as older guys. We're looking for, we made an effort to try and find reviewers outside of North America and Europe. And it really gives us an integrated perspective. Okay, this is some more data, which I won't bore you with, but basically it just shows the growth of our submissions on the left, and also how, if you break it down by country, you know, the US and China have an enormous, you know, they are by volume our biggest submitters, but the conversion rate, so the bit in yellow, I don't know if you can see this, but, you know, papers from the US have a 14% acceptance rate at the time, and this has changed. Papers from China had a 1% acceptance rate. I don't have Singapore here. Oh, Singapore 2%. I am certain this is going to be better now, because Singapore is like really in physics so strong in many ways. Okay, so then you've got the reports in, you want to make an editorial decision, and this is, again, it's a qualitative process. It's not a case of 2 reviewers say this is great, 1 reviewer says this is not great, publish or reject. You know, we listen to the arguments and we consider the referee's expertise. So in my example of that neutron scattering study, if it's my neutron scattering expert telling me these guys have rigged up their experiment wrong, this is technically flawed, that's a problem. If it's my numerical scientist, sorry, my numerical physicist saying, well, I'm not an expert in neutron scattering, but that result seems a bit funny to me, you know, we'll take that on board, but we weigh it differently. And so I think that if all 3 reviewers say, well, look, if true, this result is kind of interesting, and we just want them to check a couple of things, then that's, you know, that's good. If the reviewers tell us that there are technical problems, then we really have to sort of take those, you know, that's a problem. And so, you know, we basically have to, well, here, this just summarizes what I've just said. One thing that we try to do is avoid, I think in the past we were less good at this, but we try to avoid multiple rounds of review. We don't want to go, you know, we want to make a decision as effectively and quickly as possible, because people have, you know, a life to get on with. So if after 1 round of review, it should be pretty clear what the big questions are with the paper. And if we think it's going to converge, we will ask you to resubmit with a revised version. If we think that, you know, this is actually better published elsewhere, we will tell you at the first available opportunity, because it's in your interest to just publish it somewhere. It's not in your interest to spend 6 months arguing, you know, around in circles. And so we try to really make this a productive conversation. And, you know, the outcomes are sort of fairly obvious, I would say, after this first round of review. You know, we might suggest, great, this can be accepted. Or we might suggest, sorry, this is technically flawed, we can't publish it, or it doesn't live up to our expectation, or most likely it's like some sort of a revision process where, you know, we give you prescriptive advice as to, if you do this additional experiment, we will reconsider this, or if you can clarify this particular issue, we will reconsider it. But, you know, it will go around 2 or 3 times normally this cycle, no more than that. Okay, at this point, I kind of want to give you an option. I can describe a little bit about the history of peer review, and which I think is quite interesting, or I can describe about some other developments that we've been doing. I don't know whether you guys have any preference. Marco, would you like to choose for your for your colleagues?
Okay, so okay, I don't know if other people have other opinions. So, okay, I don't know precisely what you want to say about the history of peer review, but probably it would be nice to hear a little bit about your plans
Okay.
for the future of nature.
I will do that.
I mean, let's say I leave it up to you. So I don't know precisely what you have in mind.
No, so well, all I was going to say about peer review is that it's a relatively recent thing. Okay, so Nature. So famously, Einstein submitted this paper in 1936 predicting gravitational waves, and PRL sent it for peer review, and he was kind of outraged. He was like, you know, I sent you our manuscript for publication and had not authorized you to show it to specialists before it is printed. I see no reason to address the, in any case, erroneous comments of your anonymous expert. I'm going somewhere else. And, you know, he was right, because, you know, gravitational waves has now been measured. It took best part of 70 years, but, you know, Einstein was right. And I think that this approach of peer review that I've just described is one that we've only really formalized in the past 40 years. And I think that it's kind of, people are trying and testing different approaches, you know, blinded, double-blinded, open, post-publication, transparent. And I think the important thing to remember, and this is kind of like a little bit of a, I suppose it's something to make young scientists, give them some context, because when you're young, you're given quite a lot of pressure, I feel, in research. Like, you know, you need to demonstrate a publication record rather quickly to, you know, to get your next position. But ultimately, really, the big test is time. Is something going to be relevant? What's it going to look like in 10 years' time, in 20 years' time, in 80 years' time? And I think that in some sense, you know, my analogy here, which is a bit of a, you know, it's not a rigorous analogy, but it's essentially what we do with peer review is kind of like an ensemble average. We are asking 3 people to give us an assessment now, to try and give us some sort of idea of how this paper might be perceived over time. And, you know, it's not just 3 random data points, it's like 3 experts who really know what they're talking about. But believe it or not, even though it takes months sometimes to get a paper through peer review, this is a quicker system of establishing what, you know, what is, shall we say, more impactful than having to wait for 80 years, right? Because funding agencies, they want to know now, or at least this year, who they should be assigning their funding to. And so I think that this kind of analogy between the ensemble average and the time average is one that you should just keep in mind. It is not always the case that this ergodic hypothesis holds. We may make mistakes. We may think now, and I don't mean we nature physics, like nature physics might make a mistake, but a community may be super excited about graphene for these 10 years. Then in 80 years' time, graphene will look like carbon nanotubes. Like it will just be like, yeah, that was an interesting phase, but it didn't really lead to anything. We don't know. And so I think that there's a sort of element of serendipity to the way science is performed over time that you should never lose sight of. And I just stress this because sometimes there's this idea that, like, you know, oh, the journals are these kind of big deciders. And actually, we're not. We're really not, in a quite inherent way. And I just want to use this quote because I find this very interesting. So it seems paradoxical that scientific research, which is in many ways one of the most questioning and skeptical of human activities, should be dependent on personal trust. The fact is that without trust, the research enterprises could not function. And I mention this because I think that physics is an extremely healthy discipline where researchers basically trust each other, and us as a journal could not function without this trust. And normally this is where I end, but I have 10 minutes and I want to quickly describe a little bit about trends in the future because you know, there's this issue about open access now, which really affects us in the sense that, you know, Nature is committed to open access. And actually, as a publisher, we have a lot of experience in open access. And our mission, which I described before, that of celebrating science in front for the public, you know, that's consistent with open access. The only problem that we have is that it's very expensive to run a Nature journal. And so if you imagine 8 editors working in Nature Physics, publishing only 200 papers, you know, you just take our salaries, divide it by 200, and you realize, okay, an open access paper at Nature is going to be quite expensive. And how do we, you know, how do we square this circle? And the point is, we are squaring the circle. We're working towards sort of different ways of addressing this. The first thing is to say, you know, Nature and Nature journals like Nature Physics are now transformative journals, which means it is possible to pay an article processing charge, which is admittedly an expensive article processing charge, and make your article open access. This is possible as of this year. Now, we do this not because we expect authors to have this money lying around and making their papers open access. It's specifically so that authors that are funded by, for example, a group of funding agencies that have formed a coalition called Plan S, mostly in Europe, so that these authors can comply with their funder mandates. And, you know, and the funders, they're okay with this. The funders, you know, they understand that this is the cost, and they will make these funds available. We also have transformative agreements, which are essentially a more institutional level agreement between our company, you know, our publishing house, and the only one I'm aware of at the moment is the Max Planck Institute in Germany. So any researcher based in Max Planck, if they get a paper published in a Nature journal, it is automatically made open access. And this, for the big advantage for those authors, is that there is no kind of bureaucracy. It's just like, you know, the paper just our system picks up, oh, Max Planck author, we make it open access. And finally, and this is what a project I've been working on for the past 6 months, we have another little pilot called Guided Open Access, which involves a number of titles, including Nature Physics. And here, okay, I'm going to give you a little bit of the publishing rationale, but then also explain the editorial rationale. We spread the cost a bit differently. You know, subscription-based is basically you spread the cost over the readers. We have many readers across the world, and so spreading the cost that way is like cheaper for the average reader. If we have to flip the cost all to the authors, we only have 200 sets of authors. That is per author quite expensive, or per set of authors. So here we try to spread the cost between the submissions across many journals, and we unbundle a little bit the cost between the service that we provide. You know, I've described you how the peer review process works. So there's a cost associated with that, and then like a cost associated with the publication of the paper. So we split it into 2 installments, if you will. And from an author perspective, what this process is effectively is, you know, you would submit simultaneously to Nature Physics, Nature Communications, and Communications Physics. If we deem the paper of potential relevance to any one of these journals, we will send it out for review, and we will build you an editorial assessment report, which basically is not just compiling the reviewer reports as I've just described. It also provides you a kind of a roadmap for making sure the paper, you know, adheres to all the relevant best practice for, you know, openness, transparency, and reproducibility. And I mean, I think I have this in the next slide. Oh no, I don't. We build a report that basically will give you a roadmap for what you need to do to get this paper published in the most effective way possible in one of these 3 journals. And the long and short of it is, if you get through this process at Nature Physics, we can offer an APC which is 5,000 euros instead of 10,000 euros. And so because the costs are spread differently, this starts to become a sort of less onerous expense for you know, some authors. From just another comparison I will make between what we call the business as usual that I've just described. You know, an author would submit to Nature Physics. It takes me a week to send you a decision. That decision is maybe a rejection. So, okay, it's gone back to you. Then you submit to Nature Communications. Maybe if they don't want to publish it, it takes them 7 days to send you the decision, and they go back to you. So if you then resubmit to Comms Phys, by the time you've gone out for review, you could have waited for 3 weeks or longer. Under Guided OA, our proposition is we will hook you up with a relevant editorial guide as soon as possible. And so you can go out for review at one of these 3 journals, you know, much more effectively. Of course, there's a little bit, you have to trust us that we will find you the right home. You know, you may think your paper is Nature Physics, we may think it's Communications Physics. So, but the upshot is, you know, we decide what's Nature Physics anyway. So you know, if you trust us, we'll find you that home much more effectively from a point of view of time. I'm kind of wary that we've got a lot more, you know, we've got these breakout sessions coming up, but I'll just quickly sort of describe this editorial assessment report that we build. You know, it's a real document, and it provides this editorial evaluation, a real kind of description of how we got to our decision. It helps, you know, provides the authors with help to navigate and interpret the feedback from the reviewers. So, you know, we'll tell you, look, reviewer 2, who is an expert in neutron scattering, is telling you you need to, you know, really check this thing with your experiment. This is very important to us. This comment from reviewer 3, who's a numerical expert, and they're wondering why you're not using their algorithm, ignore it. It's okay. We don't think that's so important. we will, as I said before, guidance on, adhering to best practice on openness, transparency, and reproducibility. This is increasingly important, so how can you share your code? How can you, post your data? Where's a repository that you can use? And we'll then provide you with a very clear, like, you do these things, you get your paper in Nature Physics. You do these things, you get your paper in Nature Communications. Like, it's sort of, this roadmap that should give you a very clear idea of where you're going next as authors. And this roadmap, of course, gives you clear prescriptive next steps for doing that. It's like, it tells you how to get to this destination. And if the final thing to mention is this is, once you get this document, it's yours. So if you don't want to continue with Nature portfolio, you can decide to take it to another publisher, and we will, support the release of the reviewer identities to that other publisher. So then you can take it, if you want, to PRL. And again, that ought to make things more efficient from an author perspective. I think I'm just gonna actually finish there because we're really running out of time now. I'll stop. There are a few resources here that I can send to Marco. He can send on to you all, that I would recommend that you read if you want to get a bit more of an insight into all these topics I've discussed. Basically what I really do is I publish papers, I think about why we're publishing papers, and then I write editorials explaining what I've understood about this, and I write the editorials in the name of Nature Physics. But these concepts about guided open access, about the change of the publishing landscape, about ergodic peer review, I've published editorials about this, and you can read them in your own time. So I think I'll stop there. And I guess it's not really a question of taking questions, it's a question of going into the breakout rooms. Is that correct, Marco and David?
Okay, yes. Yeah, probably we have, so maybe I will just abuse my position and just ask you a very quick question. So you have shown this streamlined process for Nature Physics. Is there anything similar for Nature Materials or Photonics or?
Oh, that's a good question. Not yet. We would like to, so if this trial is successful, we will do it for them as well. But at the moment, it's just Nature Physics, Nature Communicate, in the physical sciences, I should say. It's just Nature Physics, Nature Communications, and Communications Physics. But we could easily envisage doing it for Nature Materials, Nature Communications, and Communications Materials. That is the, if this time, if at the end of this year, you hear about that, it means this trial has been successful, basically. Okay. But we'd like to go into that direction.
Okay, well, I guess it's getting pretty late. So, okay, Andrea, really, thank you very much for this talk, for sharing all this information with us. And now let's just give me some quick instructions about the people who booked some time with Andrea. So I've created 5 breakout rooms. I've already...
Marco, maybe we can thank all the other people that joined for the talks. So I think now the talks is over. I'm sorry we are a bit short for taking questions. So you can leave the session, and we ask the people that have booked for private to stay. Sorry, Marco, please go ahead.
No, sure. That's fine. Okay, so this is reserved only for the people who have reserved their time with Andrea. So if not, I'm sorry. That's it. So I've sent some private messages to the people who reserved their time. So now please join the room, and Andrea will be basically jumping from one room to another, and I will briefly join